All right, I got one for the first years. So it's the middle of September right now, and if you're a first-year apprentice, that means you just started school about a month ago. One of the very first things you're going to be introduced to as an apprentice is Ohm's Law. And your instructor is going to hand you a chart that looks a little something like this. Let me go ahead and make that a little bit bigger for you. Thank you, Angry Sparky, for providing this awesome merchandise. What this is the Ohm's Law power wheel. It shows 4 units of measurement and the relationship they have with each other unit of measurement on the table. Like I said, we got 4 units of measurement. We got volts, amps, watts, and ohms. But what are they? They're units of measurement. It's no different than miles or gallons. Miles measure distance, gallons measures the amount of liquid. These measure something too. Voltage is the electromotive force. In layman's terms, that's just the force behind the electrical current. Amperage is the intensity of the electrical current. Wattage equals power. More specifically, it's the rate at which power is produced or consumed. And ohms equals resistance. More specifically, it's the opposition to current flow. So as a first-year apprentice, when you're learning about Ohm's Law, you're going to be given a lot of questions that look a little something like this. Let's just say we got a toaster, right? And the question states that it's going to pull 5.4 amps at 115 volts. The question's then going to ask, how many amps is it going to pull if we apply 110 volts? And then how many amps is it going to pull when we apply 120 volts? Well, in order to figure that out, we got to find our fixed point of reference to do these calculations. Voltage can change. Amperage changes with the applied voltage. Amperage is directly proportional to voltage. What that means is when volts go up, so does the amperage, and when volts go down, so does the amperage. It's a common misconception, by the way. A lot of folks think it's the other way around. That's actually not true. And your wattage is also variable dependent on the voltage applied to the load. So that leaves one odd man out, resistance. Well, how do we figure out our resistance? Fun fact about Ohm's Law, you only need 2 values to find a third value on the table. Here we have a known amperage at a known voltage, so now we got to refer to the table. First step's going to be to find our formula. Well, we're trying to find resistance. We know it's going to be in the bottom right corner of this table here. And what do we know? We know our amps. We know our volts. Find the formula. Volts divided by amps equals ohms. So it's going to be 115 divided by 5.4 equals approximately 21.3 ohms. Go ahead and jot this down in the corner here. 21.3 ohms. So what's next? How do we figure out our current draw with a different voltage? Well, like I said before, we only need 2 values to find a third value. If we have an applied voltage of 110 volts and we know our resistance is 21.3 ohms, just need to refer back to the table. We're trying to figure out current, so we know we're going to be in this upper right quadrant here. We know our voltage and we know our resistance, so it's going to be 110 divided by 21.3. So it's going to go 110 divided by 21.3 equals 5.16 amps. And then for 120, we're going to do the same thing here. So it's going to go 120 divided by 21.3 equals 5.63 amps.